Hey, Care Bear.
All right. So here's what we did yesterday. Remember your rule for using your integration. If you have du over u, so that's an equal to the ln of u plus c. So when you guys go through these, this is like the property, okay? We let the u be the denominator. So we let u x cubed plus 3x squared minus 4. Okay. What would du be here? 98. Good job. Look at that. How is that so far? Good. Okay. Now your goal here, though, is, and Tom, we use this because you guys don't have an integration like with like a quotient type of rule. You can't do it. So this is like the idea behind what your possibility is to integrate a fraction. Up here, if you guys bring this through, we get x squared plus 2x, right? Kind of simplify that a little bit. What we want is the numerator, the du, to match. Whatever the derivative is, this du, we want it to be the numerator. Now, if we look at between 3x squared plus 6x and x squared plus 2x, what could you do? Good, okay, so what we're going to use is the idea of factoring out a 3 as like a GCF. So if you factor out that, okay, see how now we have the du there? Okay. And way back when you guys first did integration, when we did use substitution, do you remember how we did like a correction? Yeah. Okay, so we don't have that 3 up there, so we divide by 3. So we have a correction of 1/3. So when we go through, now they match. So you have x squared plus 2x, we got our x squared plus 2x, and what it becomes is the du is finding out over the u. So when we go to actually solve this, we have our 1/3 out in front, ln of the absolute value of whatever you let u be, the x cubed plus 3x squared minus 4, and then plus c. I wanted to show you guys this one yesterday, we just didn't get time, which would have helped you with number 13, I think, a little bit, if you were stuck with that one with your homework. So that's like the main idea from yesterday, that everything kind of worked out pretty nicely just by doing a correction. Now today, what you guys are going to see is a little bit different. Leave yourself some space. It is a long process.
Exactly. Not fun.
I'm going to write the steps too for you guys with this. Alright, so this is kind of a special case. And those of you guys who tried number 11 last night and you were like, oh, well, this can't work. And if we just look at the problem, if we let the u be this x plus 5, the du would just be 1. How the heck are we going to get 1 to be this? We can't. It's like impossible. So we have to use a different process, right? What we want to look for is if the degree of the numerator is degree of the numerator is equal to or greater than the degree of the denominator. Okay. What we're going to have to use is long division. I know.
Did you write den?
Denominator.
Oh.
Sorry.
I know, I thought you wrote den.
So I'm going to kind of like go through the steps as we do the problems so you guys can kind of like follow along with everything. So we look at our degrees. See how the degree of the numerator is greater than it? Okay, so we have to use long division. So when we do our long division, I know this has been a really long time ago. Okay. One thing, I mean, it's been so long, I kind of first messed up on this because when you guys are going to remember how you have to, like, it goes x cubed then x. Do you remember what you put for x squared? 0. I just didn't even think about that. It's been so long. make sure you guys rewrite everything, right? Then we would have like plus 0x squared minus 6x minus 20. You gotta fill in that missing like part. I know, or I'm with you, lady, I did the same thing. Yeah, so I used like the entire page. Okay. Space here.
I don't remember how to do this.
I know, yeah. So when you guys do your long division, right, so x times what gives you x cubed? X squared, okay? So we take our x squared, and we bring it to both of these little parts. So x squared times x is x cubed. X squared times 5 is 5x squared, right? Okay, yep, now make sure you guys do subtraction between these. Okay, so these are going to cancel. 0 minus 5x squared is negative 5x squared, and then we bring down the other stuff. X minus 20. Now you're basically doing the same thing again. So we want to think, okay, so x times what will give you guys negative 5x? Good. Because that will give you negative 5x squared. Do you guys kind of remember this stuff a little bit? No, I know. It's been a long time. 5x squared. So then we're going to take negative 5x times 5 is going to be minus, good job. And then make sure we subtract. Watch all your negatives in here. So negative 5x squared, this turns to a plus, so that's going to cancel out. This is going to turn into a plus, which will give you guys 19. And then we bring down the 20. I know, kids. Did I mess this up? Alright, now the last part of this, so x times what will give you 19x? 19, okay, so plus 19. We bring the 19 through. 19 times x is 19x. 19 times 5 is going to give us
A bigger number.
some big number. Let's see. 95? Good job.
Plus 95.
Plus 95, yep. Okay. So now we have to go through, do your subtraction. Okay. Those are going to cancel. And then negative 20 minus 95 is going to give us negative 115. Okay. And this negative 115 is our remainder. So the goal, the reason why we do this is once you guys use your long division, okay, that massive beast, okay, we're going to take, okay, we need to set the remainder over the denominator, okay, right, and then we're going to use the other factor. What I mean by the other factor is this part right here, because technically those would be the two factors of this, okay, and then we're going to integrate each. You know, integrate each separately.
Oh boy.
I know. This is the worst part, honestly. The rest of it is not too bad. So when we set this up, okay, so we're going to set the remainder over the denominator. So let's just do that part first. So our remainder is negative 115. I don't know. I'm not sure she's doing that. Yeah. Yeah. Okay. Sounds good. Bye.
No.
Okay, so, we take our remainder over the denominator, so over x plus 5. Okay. We're gonna integrate this, and then we're gonna integrate also the other factor, right? So like whatever the top part was.
And how do you get one final number?
It looks like this. You're gonna like put it together after, like
Multiply or add?
add. That's
So why don't we just do integration of that plus?
I got something. 19. Okay. You know, this is really long. Okay. All right. So here's the two pieces. What we're gonna get, and then we're gonna put it together by like a plus. We're gonna basically like add the two parts together. All right. Now, so we're gonna take them like separately. So using this one, see how you guys have a fraction? Right? So we're gonna have to use, we don't have a quotient rule for this. So we need to let your u from yesterday equal the denominator, x plus 5. Okay. What's your du here? 1. Yeah, so I should put the x on here somewhere. That notation. Okay. Close. When you guys did your u substitution, do you remember how you took out constants?
Yeah, you put them in front.
Okay. So negative 115 is a constant. So I'm going to take this out in front. So now up at the top
X
we
plus
just
5
have.
is the negative first.
Well, you're going to say that there's just 1 up there now? Yeah. Okay. So now when you look at, do you have du over u left here? Yeah. Okay, so we can use our property from yesterday that you're taking the ln of the u, which is x plus 5. Okay, put your correction out in front. Now we're not going to do plus c yet because we have to do this part too. Now on the right side, do you guys need to use ln at all? Because it's just basic. There's no fraction. You can just go for it. So here, if you guys take, what is this going to be anyway?
X
Good.
Minus 5x squared.
Good.
Plus 19.
Perfect. All right. One other thing we
Plus
need.
b.
Plus b. Good. So this
That is ugly.
this massive. No, I know it's not a joke. This massive thing.
And what does that tell me?
That tells you what the integration of.
You know how
Why
things
do I
we're
need
supposed to learn
integration?
in school are supposed to apply to life?
No.
This will never apply to life.
I don't think so.
I don't understand.
I don't think so.
Wait,
If you're engineering, I feel like that's.
Yeah, I'm doing engineering, but I don't know.
I think
don't
it's
see how
more,
use it.
I don't think you would actually like physically be like calculating this, but I think it's the idea of your, like, especially for like engineering, your upper level problem solving.
I'm not gonna
skills.
remember this by the time I leave this classroom, let alone for life.
No, it's okay.
I'm gonna go teach little kids.
It's like, here's
Yeah,
my short-term
yeah.
memory, and my long-term memory's back here, and basically
Exactly.
my phone number and nothing else.
Yep, you got a new side. I know.
My name,
So
my
those of
phone
you guys
number.
going on to like,
What
you
color
know,
am I
Cal
again?
2, Cal 3, there's just gonna be other stuff.
Thank you.
So let's do another one. Obviously, you're not gonna learn that like.
Let's say, you got some of your
So we can just leave it like
Oh,
that?
positive.
Yep, that's literally the whole big chunk of your answer.
Otherwise, I'm burned, but I don't know.
I know.
Or,
So here's your second example.
this is our 9th example.
Well, of the harder stuff. I guess overall.
This is actually our 452nd example.
Okay, so here we go. I want you guys to kind of do more of this like on your own, just make sure you can do the long division later. So here, the reason why we have to do long division, check it out. Look at your exponents, like the degree of the top is greater than the degree of the bottom.
So it can be like x to the 5th, and then on the bottom, x squared.
Yep.
It doesn't have to be like one part.
Nope, doesn't have to be one apart, just as if it's bigger or equal to. This one's nice, you guys can just go before writing it, there's no skipping of degrees.
I like synthetic division better.
I like synthetic division way better too. That other one you probably could have done synthetic
Yeah, I
division
did
for.
You
that
can do it with this.
Yeah.
That's how I did it.
Can you do it with this one though?
Yeah,
too?
no.
I think it's because
Why?
it's a square, you
Yeah,
can't.
no, you can't.
Yeah, it's gotta be a
Take
binomial.
square root of the whole thing.
That thing where you like add and
You try it, Scott.
stuff.
No.
Okay, I don't like that. I'd rather do it.
So I don't want to do it wrong and then look back
Hey,
at
wait,
those and say.
if it's a
"Well,
high
nice."
roll or the degree one on aesthetic, I don't think it's degree two bad. Huh? But anybody wants to need, like, check their, factory, this one's not as bad. Yeah, it's not bad. Yeah.
Come on, Aaron. I don't know what I'm doing. Do you have enough space? What do you?
What? I'm so confused.
People can't know. And now you do that as but that's where we're all stuck. Minus 3x.
But what's your?
That's why we're stuck. Are you stuck?
I'm not doing this.
Scott, did you get minus 3x?
Oh, yeah, we're gonna have to.
Hi, Nate.
Hi.
Nobody talks to you all day. You probably like that.
That's
I would
Stop
talk to
doing
you.
this on street beach.
He's got to go there and be
I know,
I don't talk to him. If you don't shut up all the time. Do I bother you? Hi, Brandon. It's okay to say it. Ready?
I don't even hear you guys most of the time.
Oh, good. Keep his own road.
Yeah.
You should probably do that. Hey, I'll sit over there. Yeah, bye. No, I can stay here.
What?
Hey, what was your name?
Over expert.
You just moved that over to me.
I
Oh, KK, I see that.
stuck.
I yeah.
Yeah, I want to over expert.
Oh, wait, we need a 0 on the other one? I don't know. So, okay, so this is 3x, right?
Yeah.
Okay, so 3x is what a reminder of the display term. This has to go over here.
I
thought we were looking at. Yeah, I didn't know you could just leave it blank.
So I would just leave it blank to make it easier for you, you know what I mean, when you're adding.
So then when you subtract it, that'll just come down? Okay. So then we go minus 3x.
Okay, so do that and bring everything else down.
Just put it right there.
Oh, yeah, it is.
This is the top part, it should just be the so. See, okay, so this is good right here. See this part?
Wait, what?
See this 3x?
Yeah, I did, right?
Okay, you did.
Negative 3x squared.
Hey, can I help you back there?
Okay, so plus 3x.
Yeah.
Okay, so you minus that, should just be 1x. 4x minus 3x.
That was the integration.
When you do your long division, subtract it.
Yeah. I subtract this from the first time. Negative
Okay,
3x squared
well, hang
minus.
on, can you subtract those or those?
No, you can't. So I bring that down to 3x,
Okay.
right? So then negative 3x squared minus 3x, and then you need a negative 3x, right? And then negative 3x squared.
You gotta simplify your color. You might be able to work eventually, but otherwise, you're never like, you never did anything with this.
Yeah, no.
What'd you do?
Alright,
What'd you do?
So like, do you understand, you're subtracting like everything once you get through?
that's what I got.
Okay.
Like, I know how to do like long division, but
Where did you get the minus 3?
So,
we just
yeah, just go from this with there, like, take this out. So, alright, can you write
Yeah.
down? Okay, I feel like it might be, yeah, good, like,
Yeah.
and they got a lot more practice with this last year. I think we did this like one day or something, and that.
Never mind. I was like, keep going. Sorry,
So take like that.
No, you don't have the LN to begin with.
Miss Farmer, I just got some stuff. Is that still okay?
Turn that into.
Plus 3x.
Yeah, good. Okay, now hang on a second. This is the part where we're messing up. So, 3x, does that go, let's say it's
Like, you can count 4x.
good. So we're gonna put this actually over here. We have a space.
Oh, so you just, so that'll cancel out, then you just have negative 3x squared plus 3x?
Okay,
Or plus 4x.
Because subtract, right, that's in here, so
Okay.
subtract here.
Okay, you
So,
live
minus that. Or plus
How do you have a
that.
half hour?
Wait.
It's okay. Okay, now bring that in half. Okay, now we're gonna do the same thing again. So, circle to that same thing.
Negative 3, right?
Yeah, good, you don't have to. I'll do it.
Do I leave a space here or just?
No, yeah, the up top part's fine.
I'll get it.
You know, bring this to both parts. Good. And then same deal, you do right term. Great.
So that's really.
But see, the point is,
I
have to look at my arm very
Good. Right? That was good.
Wait, why does he want me doing it? Well, I mean,
Great. So this is your remainder.
he's not always bad at it. It's not.
So now from
So,
here.
yeah, I was thinking you had to like do, like in chunks, like, I got it.
Miss Barbara, you don't know where she went. She's like a step. I was saying, can you explain it in a sec? 3 now?
This is good. This is good. Okay. Yeah, perfect. So do you want to think? X squared times what will give you negative 3 squared? Negative 3. So now take the
Excuse
negative
me,
3.
interruption for one quick announcement. There's going to be a mentor-mentee meeting after school today at 2:30 in the middle school cafeteria. Thank you.
Today, cross out, so it's negative X. Oh, we have to do 4 Oh, I did that too. Oh, so we need to I did. You have a friend write it down.
All over one.
Right, here we go, right? That's the right answer? I hope so. Is this the right answer? Yeah. Thanks, Ryan. Yeah.
Did you make this up?
Why don't you say it?
Who wrote this?
Alright, listen, for those of you guys who are done, let me give you your homework so you can like, sorry. Why? It's the bottom.
Hey, what's up, man?
It's what we learned today, so. On this one, there's only 2 questions. That's it. Can I fill your